Good morning, guys. Today's conversation will be special right triangles. You think you're special? Are you special right triangle special? Okay, so the first thing we're going to discuss here are properties of 30, 60, 90 triangles. When an altitude is drawn from any vertex of an equilateral triangle, a 30, 60, 90 triangle is formed. Okay, so in a triangle whose angles have measures 30, 60, and 90, the lengths of the sides of the triangles can be represented by x, x square root of 3, and 2x respectively. And they call this 30, 60, 90 triangle theorem. Now, how do they derive this? Well, basically, what we have here, when we drop that altitude down on the right from an equilateral triangle, equiangular triangle. So here's our right angle, that's our altitude, and we have cut this angle, so the 60-degree angle is one of our original angles, and we cut this angle in half, right? Now, the next thing we know is, let's assume that each side of the triangle is 2x. And the reason we want to assume that is because when we drop the altitude down, it becomes a segment bisector of the base, or one of the sides of the triangle. And so it's going to be half. So in this case, we got x here, and we've got 2x here. And so now, how do they derive that the last side is x times the square root of 3? Well, if I have, let's just assume for right now that this is variable y. So we would say that x squared plus y squared equals 2x squared using Pythagorean theorem. So we would end up with x squared plus y squared equals 4x squared. Now we subtract x squared from each side. Y squared would equal 3x squared. And now we take the square root from each side of this, and we end up with y is equal to x, the square root of x squared is x, square root of 3. So that's how we derive that. So that's going to be the ratio of the sides. Okay, so properties of 45, 45, 90 triangles. Okay, so if I take a square and I draw on a diagonal, I create two isosceles triangles, right triangles that are congruent. And since the base angles of an isosceles right triangles are congruent, they're both going to be 45. So all of these properties are going to pertain to isosceles right triangles. And we call those 45, 45, 90s. Okay, so in a triangle whose angles measure 45, 45, 90, the lengths of the sides opposite these angles can be represented by x, x, and x squared root of 2 respectively. So what we have here, and again, this is derived by the Pythagorean theorem, we would end up with x squared plus x squared would equal y squared, and then 2x squared. 4x squared would equal y. We take the square root of 2, excuse me. End up with 2x squared equals y squared, take the square roots of each side, and end up with x squared root of 2. So they derive it in that manner. And again, this is 45, 45, 90, triangle theorem. All right, so basically, the 6 common families of right triangles are 30, 60, 90. Okay, so 45, 45, 90, 3, 4, 5, 5, 12, 13, 7, 24, 25, and 8, 15, 17. Now, let's take a look at this from a little bit more in-depth perspective. So all of these both here, we work with angles. Those are based upon angle measurements. These here, these are all Pythagorean triples. Okay, so if we know angles, certain angles, then we can derive everything else off the triangles. And if we are given the just the sides and Pythagorean triples, all right, ratios, if we don't have any angle measurements. Okay, insert example problems here. So here I have a 90 and 60. And so right off the bat, I know that this angle here is 30, right? So triangle ABC is a 30, 60, 90 right triangle. So first thing I want to find is BC, okay? So that is the shortest side. So the shortest side is always 1/2 the height, right? The ratio is x, or here, let me rephrase this. Hold on, let me get rid of this. So the ratio is going to be always 1 to the square root of 3 to 2. You may want to jot this in your notes. And that is the short side to the long leg, I should say, short leg to the long leg to the hypotenuse. Okay, so the 30-degree angle, the side opposite that is BC. So the ratio is 1 to 2 between the short to the hypotenuse. So BC is equal to 5. Now, from the hypotenuse, or short to long, that's going to be the short side times 1 times the square root of 3, right? So the short side times the square root of 3 is 5 square root of 3. Okay, so if you can recognize these, you can get problems done very quickly, which you're going to need to do on the test. Okay, now we want to find JK and HK. So in this drawing, I am given the long side. So we're going to, again, keeping in mind, it's 1 to the square root of 3 to 2 is the ratio on 30, 60, 90. So finding JK. Now, I'm going to show you the long way of doing it. If you do not see, do you see a square root of 3 here? It's in there, but we've got to get it out. So JK times the square root of 3 equals JH, right? So 6, right? So if we want to think about that, the short times the square root of 3 equals the long. So I can say JK times the square root of 3 is equal to 6. So I'm going to divide each side by the square root of 3. And because these are going to cancel, but I've got to multiply by the square root of 3 over the square root of 3 here to get rid of this, right? So JK is equal to 6 square root of 3 over 3, which is equal to 2 square root of 3. That's our final answer. Now, is there a quicker way of doing this? Yes. I'm going to, if I don't see a square root of 3 here in that number, I'm going to divide by 3, multiply by the square root of 3. Right? If you notice, 6 divided by 3 times the square root of 3 gives me 2 square root of 3. Now that's JK. HK's got to be double that, so it's just going to be 4 square root of 3. Okay. So MOPR is a square. Find MP. So we know this is 9, and since this is the diagonal, it's so the ratio is 1 to 1. Dots come up here, I don't know why. Let's try this. 1 to 1 to square root of 2. Okay, so 1 to 1 to the square root of 2. So MP 9 square root of 2. Okay, find ST and TV. Now, again, this is X and this is X. Now you could do it the long way. X squared plus X squared equals 4 squared 16, right? 2x squared equals 16, do all that work. Or you can sit down and say, okay, I know this ratio is 1 to 1 to the square root of 2. So, I know that TS or TV, TS times the square root of 2 equals VS, which is 4. So again, divide by square root of 2. These are going to cancel. I'm going to rationalize this by multiplying by the square root of 2 over the square root of 2. I end up with TS is equal to 4 square root of 2 over 2. And so my final answer is 2 square root of 2. Is there a shortcut? Yes. Divide by 2, multiply by the square root of 2. Divide by 2, multiply by the square root of 2. So you'll notice 30, 60, 90. Those is when we're trying to, if the long leg has no square root of 3 in front of it, or on it, then it is just divide by 3, multiply by square root of 3. How do we remember? 30, 60, 90. Everything's got 3, factors of 3. Since this is isosceles, everything deals with 2, square root of 2. That's a way you can remember these shortcuts. What's going on?
And so I cry sometimes when I'm lying in bed just to get it all out what's in my head. And I need a peculiar. And so I wake in the morning and I step outside and I take a deep breath and get real high. And I straight to the top of my lungs. What's going on? And I say, hey, yeah, 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 yeah. my life is still trying to get off that great big hill of hope for a destination.
What's going on? Now that's stuck in your head.
That's all, folks.